So I cut my hair, and my wife says I look less like a recently divorced guy who is not doing okay. So that's pretty good. Hello. One of my favorite things about Pokemon is being able to grow and advance your little characters through leveling them up through play. So let's implement level ups. In this video, we're going to add an experience and level up system and have that reflect in monster stats. Later on in the next video, we're going to handle move swapping and management. So come back for that. This is the 12th video in this series. We're building a Pokemon clone in Godot from scratch, more or less, with a deep emphasis on data structures and custom resources. If you are lost, the beginning is at least as good a place to start as any, and some might say it's the best place to start. So there's probably a link for that somewhere. There are a couple ways to do stats. We could just store stats as a value we accumulate on level up, or we could derive them based on current conditions and level, which is what I'm going to do. It's a bit less error prone since then we don't have to remember to increase and reduce stats when conditions apply or expire, or when we level up. And we can better handle float values and accumulating different bonuses. All right, let's figure out character level ups. First thing, we can look at our monster data class. We don't have a concept of experience yet, which should just be an integer here. I don't think there's a reason to store it as a float, so we'll store that and level 2 also as an integer. Now, what happens when monsters level up? They probably get some new stats and they might learn a new move. So let's handle stats for now. I don't know the exact calculations used for determining Pokemon stat gain per level, but you can look at them and implement them yourself. They are not too hard. It's just some simple math expressions. You'll want to tweak them anyways for your own game. But there's a few things at play here for our calculation, which we're going to run anytime someone requests a stat number. We're not going to store this specifically. It'll be based on levels and conditions and whatever else you want to add. So in species, we will have these base values. Also, we want individual monsters to have something like effort values that influence how fast stats should grow. So I'm going to add these to the monster class. We'll have VAR, HP growth, attack growth, def growth, and whatever the other one is, speed growth, I guess. And they're just going to be floats. And these values will be generated on the birth of our monster. And let's give our monsters HP growth. Well, I think we could just use our RNG service. Remember, we created this so that all model code would run with the same random seed deterministically. Anyways, let's set it between two numbers, and I think you can tinker with this as much as you want, but I'm going to do 0.4 and 1.2. Then we'll copy these for our other growth values. Now, when we do our calculations for max HP, etc., we can incorporate our growth values to multiply to get amount changed by level. But these are going to get really wild living in monster.gd, so I want to move them to live in calculations.gd instead. We'll create a new function for calculate monster stat, and we'll have base, which is an integer, growth, which is a float, and level, which is an integer. And what else do we need? Well, let's take stat code for like hit points, defense, etc. And then we can grab code from monster and return it from calculations. We're also going to need to get the sum conditions in. So let's pass in condition bonus 2 as an int. And then we can just add these up. So it will be base plus level times growth plus condition bonus. And I'm going to clamp it between 1 and 999 because zeros or negative numbers might screw this up, and anything really high might also be bad too. But you can change that if you want. I think in Pokemon, we're also going to have it grow with respect to base. So let's multiply by base divided by 10 also. So a creature with a larger base will have somewhat larger growth. Now let's update all of our stats calculations to use the new calculations, and I'm just going to speed through this because it's pretty repetitive. Okay, it looks like the game's running okay. Now if I change it to hard code level to 20 and run the game, you'll see that the monsters now have improved stats, and we are calculating that from the level, probably. Great. And I'm just going to remove the level equals 20 and look at how we can calculate experience. So let's define the cost of each level in experience. We could always define an array for experience for each level. That's fine if you want it to be really specific, but I'm just going to write a quick calculation. So I'm just going to make it so each level costs by itself 200 times the level. Again, this is something you need to tinker with yourself because I have no idea what game you're making exactly. And we'll add a function here that can calculate the experience you get for defeating a monster too. I'm just going to do 20 times monster level. For both of these, we might want to work in some sort of species coefficient that slows leveling or gives more experience for rarer or harder species, but you can figure that out on your own. Just add some values to our species resource, I guess. Great. Now, how do we actually use this? So I'm going to look at Game Runner, and if we find a code where we deal with monsters being defeated, we can put a hook in here to deal with experience. In this case, the player monster has 0 hit points, so we'll give the experience to the enemy monster. Down here, we'll do the opposite, giving it to the player monster. I think we want to handle experience in monster controller, so we'll add a function add experience to monster with monster and experience. Well, first we can do monster experience plus equals experience, and this is not great because, well, if we get more experience than the level is worth, this could be a problem, so we should check for that. We'll still add experience, but we want to have a while loop here that will keep leveling up the monster until they have less experience than they need for the next level. Why a while loop? Well, what if we give our monster enough experience for many levels? In this case, we want to level them up repeatedly. So for each loop in this while, we want to reduce the experience by whatever the calculated value is, and then we want to run a level up monster function. So in this case, we'll give 2,000 experience, and they need 300, so we'll do a level up, and then they'll have 1,700 experience left, and they'll do another one until they cannot run it anymore. So for the level up monster func, we will do monster level plus equals 1, and we can maybe emit a message via the AVFX manager to say that the monster has leveled up to level whatever. We'll format that with the monster name and the level. Excellent. So what now? Well, this should work more or less fine because we're deriving all the stats. We don't have to do anything else. We don't need to update any of the stat values because they are all being calculated through our getters. I'm going to put a to-do here for handling moves, which we'll do next video. And that's going to take a bit more work, actually, because we have to actually write some UI to switch them. Anyways, let's test this out. I'm going to change how much value you get out of a monster so we can see this in action. And testing. We need to give the enemy more monsters so we can actually see this in action. We're adding another turtle here. And I'm going to make turtles a bit weaker so I can test this quickly. Okay, trying. And killing one turtle didn't give us any experience. And why is that? It's because we haven't actually finished setting this up. So in Game Runner, let's find out where the fainting happens, and we'll run add monster experience for the enemy and the player. And we'll make sure we adjust the monster variables to make sure that the player gets experience when the enemy faints, and vice versa. Running it, and we get a crash. It's freezing. That's great. We'll hit the debugger and see where we're stuck. It's definitely something to do with this level up function. And I will mess around here, and we'll see that the loop is wrong and running forever. It should be greater or equals to, not less than or equals to. So, good. Oops. Okay, it's not crushing now, but we're still not getting levels. Why is that? Let's see if we're hitting the monster level up. We are, but his level is starting at 0, which is a bit weird. Level should go up to 1 here, and I think the issue is that we had such a low level that we didn't get any experience at all. So I'm going to juice up the experience gain calculation a bit so it's a bit more obvious. Okay, now it's only leveling once, and it's not passing any experience value, just 0. And that's because monster level is still 0, and we're multiplying by it. So let's make sure the monster level starts at 1, and that should fix everything. Okay, now we get experience, but it's still not updating until we do something else, which means we have to make sure we call update on the UI too. So events on monster updated.emit monster. Okay, cool. We're hitting another bug here where we're trying to push an AVFX instance while there's already one in flight. So let's fix that. Our message panel's AVFX instance was getting overwritten, which is a problem because it needs to be able to finish them. So I think we need to make a queue for these also. The input can be the same. We just need a var instance queue array AVFX instance. And now the major difference here is that when we queue messages, we probably want to check if there's already an instance. And if there isn't, we just run it. Otherwise, we append into the instance queue. We'll add a function run instance down here. It's going to make current instance our instance. It's going to empty the message queue, and then it's going to loop through each message in the instance and append them. And then we want to show the current message, show message, message queue.pop front. And that kind of replaces all the stuff in queue messages. And instead, we can check if current instance is null, and if it is, we run instance on the instance. Otherwise, we instance queue append instance. Okay, so that's a bit of a mess, but I think that will fix it. We have to check if instances are in the queue when we finish our current instance. If message queue size is 0, we check if current instance does not equal null. And then we get current instance and set it to null. Then if instance queue size is greater than 0, we can grab a new instance. Instance queue pop front. And actually, we can just run instance on that. Then we want to keep emitting on message panel end still. I think we need to put that in an else. So if there is no instance, we can unblock it. And let's test it. Now we're storing 2 queues. Hopefully that works, and it still doesn't. Why? Maybe we need to test here in queue free. Wait, though, this doesn't make sense because we're already checking if it's null. I'm going to run it again in the debugger and wait for it to time out. It times out, and we've got current effect group. Step over, step over, step over. And at this point, current effect group becomes null. What does finish do? This should be an instance, right? Oh, because finish can remove the parent effect. So that's fine. We actually don't need this because it never gets called. I think there's still a problem because it's timing out, right? Okay, so what's happening here? I'm having a look at the remote, and I'm looking at which message is timing out, which is all of them, and Flash Monster. That's the problem, I think. Really? Let's have a look at the code. It's emitting Flash Monster. You know what the issue is? Since the monster is not existing to flash at that point because it's being swapped out, we've got these early returns, and we can't return. We have to AVFX instance finish and then return. So anytime we have one of these early returns, we might need to run finish also for these events that catch AVFX. So let's see if this works. Okay, it's now hanging, but that works now. Fun little problem with asynchronous code. Okay, so we have level ups happening now, and stats are getting affected and updated in the UI, and that's good. And it's working, basically. So I'm going to change the value back in calculations so it's less crazy. And that's the basics of level ups. You can tweak the numbers however you want. I think the one main thing here, though, is that I've made a choice to calculate attributes based on level, species, effort values, and conditions every time we run it, rather than store a integer for that. I think it's a bit better because I think it's just less bug prone, and running those calculations is not enough to be a performance issue. I think it's just a little bit of math. All right, the next thing I want to do is deal with start states. So by this, I mean we're going to create a new resource that will let us define how we start a battle, and it will handle all the stuff that we do in this awful game runner setup function here. So we can make this into a configurable resource, and it will clean up stuff a ton, and it will let you slot in different scenarios for battles and let your designer do that too. And if you are integrating this with a overworld system, which hopefully you are, you'll want to tweak this a bit so that you can input your player's team and stuff from game data. But that's not going to be a huge difference. I believe in you. So let's go to scripts, content, and make a new script called start state. It's going to be a resource, and it needs a class name start state. And what does that get? Well, it needs to keep track of 2 trainers, and we don't yet have a resource for trainer values, so let's make that 2. So the resources we are going to start adding here are a bit different than the ones we've used to back monsters and items, etc. So those contain some sort of invariable information about those things, the monster's name and icon, the move effects, whatever. But these resources are different. They're going to just store values that we'll read from and copy when we generate our start states, and we'll never need to keep references for them for later. So let's call this one trainer start state, and it won't have anything we need to refer to later. And let's do an export var player start state and export var opponent start state, and give them both types trainer start state. In trainer start state, I think we need to give them a name and a list of monsters. And we're going to need a new resource that holds the start state of a monster, but not any of the persistent stuff. We'll call this monster start state. And what do we want here? Let's do a nickname, which is a string, a species, which is a species resource, and let's also add a level here. You could also add experience if you want, but I'm not going to write all of that out. So trainers now need an array of monster start states, and we'll give them an array of items too. And let's make an item start state too, so we can include that. It will have a item and a quantity. You could probably do this a dictionary too, like item to number, but I think it's a little cleaner to do it this way. Anyways, so we can specify quantities of items to get at the start. I'm going to do a little organization here and make a start state folder and put our new resource scripts in because they are all related. Now let's go to content and create a new folder for start state. And now we can create something inside of it. I'll make a new start resource called default, and we can add a player and an opponent with names, monsters, and items. And now that that's done, we can do setup model in Game Runner and clean this whole mess up. We'll preload the start state, and we can move everything here into a function called generate state from start state. And it will take in a start state. And what do we do here? We'll cut and paste everything from our setup model below our call into this, and then we can slim it down. So we don't need to preload specific resources for species since the start states already have those references. So let's delete all of this, and let's reorder this a bit. I think we want to make our trainers first. We'll make the player and opponent up here with trainer controller, and this might get a little messy, so let's actually add a generate function to the trainer start state resource. We'll create the trainer, give it an isPlayer value. And make sure we actually use the trainer controller so that it binds everything correctly. And then let's figure out the monsters for this. We'll make an array of generated monsters here. For monster and monsters, monster.generate, and we'll have to add a generate function to monster. Func generate returns monster. Monster equals monster controller dot create monster with the species and nickname. And we can just give it a level and return it. Excellent. Okay, now we can pass those monsters to trainer, and let's get those items. We'll use the exact same pattern and create a generate function in item start state. And since we just add an item with a resource, we could just use this actually, since items are much simpler than monsters or trainers. And if they get more complicated, feel free to create a full generate function for them, or if you care a lot about consistency. I kind of wish I did that because I think consistency is nice, but whatever, up to you. So trainer controller.add item, trainer, item resource, and item quantity. Let's add a trainer name too, and this should generate everything we want about the trainer. And we can now get rid of all of this and call start state.players start state generate trainer. Same for opponent. And remove everything else. And that's the entire start state, I think. Let's try to play, and it's going to fail because generate trainer is not a real function because it's called create trainer. Whoops. Classic blunder. Okay, new bug. Add trainer monster to battle is having an indexing issue because the trainer has no monster. But why is that? So something is wrong with generated monsters, and that's because we're not adding our new monsters to it. So it's append, not add. Great. And we'll run again and hit another issue. As usual, we can't append to items because there is no game state player, but that's good because this should just be trainer.items. That was a bug. So we fixed that, and now if we run it, we see Dino and George, the correct monsters. But note, we're not setting the hit points to the correct values based on their levels. So let's make sure that we set HP to max HP. Okay, everything's working fine. I think looks pretty good. And yeah, I'm going to say that we now have a better start state method. And now you have a new way to create start states without messing with code at all. Okay, huzzah. Thank you for watching my video. I've got one more in this series, probably, maybe two, probably one. And we're going to handle monster move management so that you can add and remove moves on level up. And I'll also do a little bit of work with UI tweaks also. So thanks for staying with me for so long. If you have any requests on what I should look at next, you can put them in the comments. I may not do them because I've got lots of ideas of what I'd like to cover next, but yeah, there will be more stuff. So, follow me. Otherwise, see you in a couple weeks for a possible grand finale, and watch out for falling rocks. Goodbye.